Now we know the meaning of the terms displacement, velocity, and acceleration, it's time to put all these together into what I call the kinematics formulas, or they can also be known as the constant acceleration formulas. So these formulas allow us to calculate the motion of objects when acceleration is constant. So note, the formulas only work in cases where the acceleration is constant, otherwise they don't work. There are 5 of these formulas, and they relate to the following 5 variables. So S is displacement, U is the initial velocity, the velocity at the start of the motion, V is the final velocity, the velocity at the end of the motion, T is the time, and A is the acceleration, and this must be a constant number. So the 2 key kinematics formulas, in my opinion, are, first of all, S, or displacement, is equal to the initial velocity plus the final velocity divided by 2 multiplied by time. Now note that the u plus v divided by 2 is a special term that we call the average velocity. So this is essentially saying that the displacement is equal to the average velocity times the time. The second key formula is that acceleration is equal to v minus u divided by t, or the final velocity minus the initial velocity divided by the amount of time. And this is essentially the definition of acceleration, that acceleration is just the change in velocity over time. Now note, there is a second way that you can write this equation. Often it is written as the final velocity v is equal to u plus at, or the initial acceleration, the initial velocity plus the acceleration times time. But these 2 formulas are entirely equivalent. So you can get from one to the other using algebraic manipulation. So you only need to learn or remember one of them. Now with these 2 equations alone, it's actually possible to solve all kinematics problems. However, there are 3 more that we can use as well, and it's often easier. It allows us to take a shortcut if we use these 3 derived formulas. So the first one is the displacement is equal to the initial velocity times the time plus half the acceleration times the time squared. The next one is the displacement is equal to the final velocity v times the time minus half the acceleration times time squared. So note, those are very similar, those 2 formulas. You just change the u for a v and then change the plus to a minus. And finally, there's also v squared minus u squared is equal to 2as, or 2 times the acceleration times the displacement. So note that even though these 3 formulas can be derived from the first 2, they are very useful. Because now, in those 5 formulas, each one has one of the 5 variables missing. This means if we were given any 3 variables, there is one equation that would allow us to solve directly for any 4th variable. So these are the constant acceleration formulas.